Looking up at the night sky, you see maybe a few thousand stars on a clear evening. Your brain tells you that's the universe. But what if I told you that in a patch of darkness no bigger than a grain of sand held at arm's length, there are nearly 1 million galaxies, not stars, galaxies, each containing billions of stars. And what we just discovered inside them is forcing scientists to completely rewrite the story of existence itself. The James Webb Space Telescope just shattered every assumption we had about the early universe. And what it found hiding in the darkness is almost impossible to believe. Welcome to Beyond the Stars. For generations, we've been blind to most of the cosmos. Our eyes evolved to see a tiny sliver of light, the colors of the rainbow. But the universe speaks in a language we couldn't hear, a wavelength beyond our natural vision, called infrared. This invisible light carries secrets from the birth of time itself, traveling through expanding space for billions of years, stretching and shifting as it journeys toward us. The oldest light has traveled so far, for so long, that by the time it reaches Earth, it has transformed completely, sliding past the visible spectrum into the infrared realm. Our faithful eye in the sky for decades could glimpse this light, but only barely. It was like trying to read a book in almost complete darkness. You could make out shapes, guess at meanings, but the full story remained locked away. Then came Webb, a machine unlike anything humanity has ever built. Its massive golden mirror, nearly 3 times wider than Hubble's, collects infrared light with breathtaking precision. It doesn't just see farther, it sees what was always there but remained invisible, hidden behind curtains of cosmic dust, and stretched beyond the limits of what older telescopes could detect. Armed with this new vision, scientists pointed Webb at a region of sky and told it to stare, not for hours, but for more than 250 hours. The telescope captured thousands upon thousands of exposures, each one peeling back another layer of cosmic history. When those images were finally assembled, stitched together into one coherent whole, the results stopped astronomers in their tracks. They called it the Cosmos Webb Field, the most expansive and detailed map of deep space ever created. Inside this single image, packed into a region of sky roughly 3 times the size of the full moon, scientists catalogued 780,000 galaxies. Let that sink in. 750,000 galaxies in one photograph. Each one a cosmic island, each containing its own billions of stars, its own planets, its own untold stories. But the real shock wasn't just the quantity. It was what these galaxies revealed about themselves. Remember that famous Hubble image from 2004? The ultra-deep field. Hubble stared at what looked like empty blackness for 11 days straight and found 10,000 galaxies hiding there. That image revolutionized galaxies in the castle. Astronomy. It showed us the universe was far more crowded than anyone imagined. Scientists used it to estimate that the observable universe might contain 2 trillion galaxies total. That number seemed almost incomprehensible. Now picture this. If you printed the Hubble ultra-deep field on a standard sheet of paper, the Cosmos Webb map at the same resolution would need to be printed as a mural over 13 feet wide and 13 feet tall. We didn't just zoom in. We expanded our view of reality by orders of magnitude. It's the difference between knowing your neighborhood and suddenly seeing the entire continent spread out before you. Rivers and mountains and cities you never knew existed. What makes this map truly extraordinary is that it's not just a snapshot of one moment, it's a timeline. The light captured in this image comes from galaxies at vastly different distances, which means vastly different points in time. Light travels fast, but space is incomprehensibly vast. The light from nearby galaxies in this map has been traveling for just a few billion years. The light from the farthest galaxies has been journeying for over 13 billion years. When we look at those distant points of light, we're not seeing them as they are now. We're seeing them as they were when the universe itself was still in its infancy. Less than 300 million years old. We are literally looking backward through time. As we scan across this cosmic tapestry, patterns emerge. In the relatively nearby regions, galaxies appear mature and fully formed, elegant spirals with graceful arms. Massive elliptical galaxies, glowing with the light of trillions of old stars. Irregular galaxies, twisted by ancient collisions. These structures aren't scattered randomly. They gather into enormous clusters, connected by bridges of matter, forming what astronomers call the cosmic web, a vast interconnected network that spans the entire universe. Hidden among these structures, Webb found something nobody expected: two galaxies caught in the act of merging, their collision creating a shape that looks exactly like a glowing figure eight. Scientists dubbed it the Infinity Galaxy. But here's where it gets truly bizarre. Right in the middle, in the space between the two galaxies, a supermassive black hole appears to be forming. Not inside either galaxy's core, where black holes normally live, but in the gap between them. This suggests a completely new way that these cosmic monsters might be born, a process we've never witnessed before. If you've been as mind-blown by these discoveries as we are, hit that subscribe button and drop a like. This is just the beginning of what Webb is revealing, and you won't want to miss what's coming next. Now we travel deeper into the map, further back in cosmic time, to an era astronomers call cosmic noon. This was about 10 billion years ago, when the universe was roughly a quarter of its current age. During this period, star formation across the cosmos reached its absolute peak. Galaxies blazed with the fierce light of newborn stars, churning out solar systems at rates that dwarf anything we see in the modern universe. But even here, in this age of cosmic fertility, Webb is rewriting the textbooks. It has discovered quenched galaxies, systems that somehow turned off their star formation engines completely. They sit there, dormant and red, surrounded by galaxies burning with the white-hot fury of stellar birth. According to everything we thought we knew, these galaxies should have been at their most active. Instead, they went to sleep billions of years too early. Webb also found beautifully structured spiral galaxies with clearly defined arms, existing just a few billion years after the Big Bang. The problem is, galaxies aren't supposed to be able to form such organized structures that quickly. It takes time for gravity to sculpt matter into such precise patterns. The simulations, the mathematical models, everything we built our understanding on said this couldn't happen. And yet, there they are, spinning elegantly in the ancient cosmos, impossible and undeniable. Then we reach the edge of time itself. Before Webb launched, our best cosmological models painted a specific picture of the early universe. In the first few 100 million years after the Big Bang, only a handful of small, dim, primitive galaxies should exist. Matter had barely begun clumping together under gravity's patient pull. The first stars were just igniting. Everything should have been faint, scattered, and simple. Webb obliterated that picture completely. Instead of finding a few faint smudges, Webb discovered a shocking abundance of bright, massive galaxies at distances that should have been nearly empty. One by one, records for the most distant galaxy ever observed began to fall. First came a galaxy called JWST-16, shining brilliantly, despite existing only 290 million years after the universe began. Then an even more extreme discovery, a galaxy that existed just 280 million years after the Big Bang. These aren't the fragile proto-galaxies scientists expected. They're already complex, luminous systems. And when Webb analyzed their light, breaking it down into its component wavelengths, it found something that borders on impossible. These ancient galaxies already contain heavy elements: carbon, nitrogen, oxygen. Elements that can only be forged inside stars and scattered across space when those stars die. This means that entire generations of stars had already been born, lived their complete lives, and exploded as supernovae, all within just a few 100 million years. The universe wasn't taking its time in those early days. It was racing forward at a pace that our models say shouldn't be possible. Gravity doesn't work that fast. Star formation doesn't happen that efficiently. Galaxies don't mature that quickly, except apparently they do. Astronomers are scrambling to understand how the universe could have been so productive, so organized, so mature at such an impossibly young age. Every discovery from the cosmos Webb field demands new explanations. Maybe supermassive black holes formed earlier than we thought, seeding galaxies faster. Maybe the physics of the early universe operated differently in ways we haven't accounted for. Maybe our fundamental understanding of how matter behaves under extreme conditions needs to be revised. What's clear is this: the opening chapters of cosmic history are far richer, far more dramatic, and far more crowded than we ever imagined. We thought we were looking at a quiet beginning, a slow gathering of matter in the darkness. Instead, we found a universe exploding with activity, with structure, with light. And perhaps the most humbling realization of all is that even this record-breaking map, this monument to human ingenuity and curiosity, captures only the tiniest fraction of what's out there. The cosmos Webb field represents just one patch of sky. The universe extends in every direction, filled with countless billions of galaxies we haven't even begun to catalogue. We are standing at the threshold of a new era in astronomy. The James Webb Space Telescope has given us the ability to witness cosmic dawn, to see the universe when it was young and wild and nothing like we expected. Every image it sends back challenges us, surprises us, forces us to question what we thought we knew.